Hello. In this session, we will explain the working of another very common internal combustion engine, namely the diesel engine. So, in the previous lectures, we have explained the construction, working, as well as the efficiency of a gasoline or a petrol engine. And you will see that the diesel engine is another variant of internal combustion engine, which has got almost similar working principles to that of the petrol engine, but also it is characterized by certain differences, and that makes a diesel engine entirely just different and suitable for operation in heavy vehicles. Commonly the engines of heavy vehicles like the trucks, the bus, etc. are usually using the diesel engine, and we will see what makes a diesel engine different in terms of its performance, and which makes it suitable for use in such heavy vehicles. Now, to begin with, you will see that the diesel engine was developed historically after the gasoline engine. It was invented by a German engineer named Rudolf Diesel, and hence the name diesel engine. Now, it was in the year 1897 for a historical perspective, and he constructed this engine. And as I told you, the construction is almost similar to that of a gasoline engine with some differences. We will just discuss the differences here. So, hope you remember the basic construction of a gasoline engine. There was something known as an inlet valve, there was an exhaust valve, there was a piston connected to a rod, and then finally onto the crankshaft, and we had what is known as a spark plug in the middle, which is used to produce a spark in order to begin the ignition stage or the combustion stage of the working. But here, as you can see from the figure that I have used over here, that there are two major differences. One is that in place of the inlet valve, here we have named it as air valve. Actually, this is an inlet valve itself, but it is specifically named as an air valve. You will understand because while in a gasoline engine we are compressing a mixture of petrol with air inside the combustion chamber. In the case of a diesel engine, we let only air to be compressed. Means we do not mix air with diesel. Instead, we allow only air to enter the cylinder initially. Air is entering the cylinder initially during the intake stroke, and this air will be compressed to such high temperatures that by just supplying or spraying diesel into that mixture, it gets fire. So that is a major difference that you have to always remember when compared to a gasoline engine, where petrol air mixture is getting compressed in the adiabatic compression stroke. In the case of a diesel engine, air only is compressed during the compression stroke. That is a major difference. And the spark plug in a gasoline engine will be replaced by another valve, or we can say that another supply valve, that is known as the fuel supply valve. So a fuel supply valve, as you can see in the diagram here, it is replacing the spark plug that was an integral component of the petrol or gasoline engine. Now, that is a major difference in the construction of a diesel engine. And one more idea I would like to share is that, hope you remember, in the case of a gasoline engine, the combustion was occurring under isochoric conditions. The combustion occurred in the case of a gasoline engine was under isochoric condition. The combustion was so rapid that the volume of the combustion chamber practically remains constant during the process of combustion. So we named it as an isochoric combustion stage. Okay, the combustion stage. Now in the case of a diesel engine, there is a major difference here. In place of isochoric combustion, here we are having an isobaric combustion. So that is a notable difference here. Remember that the diesel engine will be undergoing, or the engine will have a combustion stage which happens almost at constant pressure instead of constant volume. So that is an isobaric combustion, and I will explain in detail how that is made possible, and what is the major difference in the PV diagram maybe in the next slide. So these are the major differences or major features of a diesel engine. The thing is that there are two or three major differences which I have pointed out here. See that you can just recall it. Only one difference is that air only is compressed instead of the petrol air mixture in the during the compression stroke, and the spark plug in the gasoline engine has been replaced with a fuel supply valve. And the third one, the combustion happens under a constant pressure condition instead of constant volume condition. That was a feature of the gasoline engine. And you can see this figure. So the position of the spark plug has been taken up by a valve here, which is just spraying diesel into very fine particles. So in order to catch fire, the diesel molecule should be sprayed into very fine particles, and that is the role of the fuel supply valve here. And inside the combustion chamber, what you see here is compressed air that is there. Okay, all other things will remain almost the same, and just you note the major differences, and it will help us to just explain the working very easily. So let me go to the next slide, which explains the stroke by stroke or stage by stage working of the diesel engine using the PV diagram. So here we have the PV diagram or the indicator diagram here. So just have a look at the indicator diagram. You will see that the indicator diagram looks almost very similar to what you have seen with the case of a gasoline engine PV diagram. But on a close look, you will understand that there is one major change in the PV diagram. Hope by the time you would have realized what is the difference, you would have noted the difference. So for reference, I have just added the PV diagram of working of gasoline engine at the bottom of the figure. So you can see that the PV diagram, it's all remaining the same everywhere. 5 to 1 and 1 to 2, up to there it is same. But from 2 to 3, you just note the stage 2 to 3 here. So in the case of a diesel PV diagram or top diagram, you can see 2 to 3 is flat or parallel to the volume axis, or it means that the 2 to 3 is occurring at a constant pressure here. So let me say that this is some pressure P. Okay, so 2 to 3 process occurs at constant pressure. So that is why I named this process as isobaric process. Whereas just note the diagram of gasoline engine. You can see the stage 2 to 3, which represents the combustion stage. It's not a stroke, it is combustion stage. 2 to 3 was vertical. Vertical means it is parallel to the pressure axis. So it means that the process 2 to 3 was isochoric there, constant volume process there. But here it is constant pressure process. So that is the major notable difference between the working or the PV diagrams of the two types of engines. And due to this reason, a diesel engine is also known as constant pressure cycle engine, and the other one is a constant volume cycle engine. This is a constant pressure cycle engine. And as I had told you, in the case of gasoline engine, we will be discussing an idealized diesel engine which is using air standard. So this is known as the air standard diesel cycle. What we explain here is known as a air standard diesel cycle, because that is based on a lot of assumptions. Whatever assumptions we had made in the working of a gasoline engine is followed without any difference in the case of a diesel engine also. Remember, that is a very important theoretical assumption that we have made, because the usual troublesome effects like the friction between the piston, the conduction of the cylinder, all those things are occurring in the case of a diesel engine also. The problems remain the same. So that is where we begin with. So the difference you have already noted, and due to the change in the PV diagram, one more thing you can note, that we had only two relevant volumes in the case of the working of a gasoline engine. We named it as V1 and V2. So you can see V1 and V2 were the only two relevant volumes in the case of a gasoline engine. But when you come to the case of a diesel engine, you will see that there are three relevant volumes: V1, V2, which are the same role as that of the petrol engine, and we get one more relevant volume here that is to be noted, which is known as V3, which I have named as V3 here. So V3 is a third volume that comes relevant. That is due to the flattening of the portion 2, 3 in the PV diagram. Earlier it was vertical, so 2 and 3 were having the same volume. Now 2, 3 is flat, so 3 will give rise to an intermediate volume, I should say. V3 is an intermediate volume. You can see V2 is less than V3 is less than just V1. So that is the thing. So V1 is the highest of all the three, and V3 is an intermediate volume, and that V3 is a new addition in the PV diagram. So note that accordingly. So let me to begin with the description, let me start with the points over here. So let me name the temperatures at each of the significant points in the cycle, the diesel cycle. So cycle is 1, 2, 3, 4, 1. So it's a cycle 1, 2, 3, 4, 1. That is a closed cycle. And as we have explained previously, 5 to 1 and 1 to 5 will be getting mutually cancelled out. So that is not usually counted in the efficiency calculation. So let us assume that at point 1, the temperature as usual, let us name it as T1. At point 2, let the temperature of the working substance be T2. So air is the working substance over here now. Okay, and now at 3, let me say that T3 is the temperature, and at 4, let's say that T4 is the temperature. And the magnitudes of T1, T2, T3, T4 remains the same. The comparative values of T1, T2, T3, all these temperatures remains the same as in the case of a gasoline engine. So no worries about that. So let me come to the basic working. So remember, I need not repeat the entire process, because there is only one notable difference with the working of a gasoline engine, that is in the stage 2 to 3. Okay, all other processes practically remains the same. All other remaining 5 processes remain practically the same as that of a gasoline engine. Okay, that is what you have to note. So for the completion, let me just quickly go through the processes. So as usual, we begin with the process of intake, which is regarded as a stroke. Remember, the diesel engine is also what we are explaining here. This is also a 4-stroke process, whereas there is the 2-stroke variety of the diesel engine is also there. Now we are discussing the 4-stroke diesel engine. This is the common variety, the 4-stroke diesel engine. So you will see the same 4 strokes here: the intake stroke, the compression stroke, the power stroke, and finally the exhaust stroke. So there is no difference at all. Now in the beginning of the intake stroke, what happens is that air only, that is very, very important, that is a difference. So air is air at atmospheric pressure, at constant pressure, let's say at P0, So that's an isobaric process, as you can see in 5 to 1 PV diagram. So this is happening at a constant pressure of P0. So at a 5 to 1, that is the intake stroke. Intake stroke happens at a constant pressure P0, where air only is taken, okay, into the particular cylinder. Air is taken into the cylinder, which comprises the intake stroke, and so the volume, you can see that from 5 to 1 the volume is varying, right? Because as I have explained previously, the piston was initially, imagine the piston was initially at its dead center, means to the top in our previous diagrams, and the piston is drawn back. Piston is drawn back, like the case of the piston of a syringe. So volume increases from, I can say, during that process volume increases from 0 to, say, which value? Finally at the end 1, V1, 0 to V1. Volume increases from 0 to V1. So what will happen? Number of moles will increases from N, increases from also 0 to some N value. That is, number of moles also increases from 0 to N. So what will be our equation of state here? The equation of state will be, I can write by the end of this process. At the stage 1, I can write the equation of state will be P0, right? The pressure is P0 at point 1. P0 into the volume there is V1. So that should be equal to N into, right, the number of moles taken into, number of moles of air that is taken inside is N, R into the temperature, that is T1. So that will be the equation of state at stage 1, means at the end of the intake stroke. Sorry. Now process 1 to 2, you can see it is nothing different from the that of gasoline engine. It represents a reduction in the volume. You know, the piston will be moving up, which represents a compression stage. The difference is that air is only getting compressed. So air is compressed. Air is compressed adiabatically, quasi-statically and adiabatically. So that is an adiabatic compression. So the stage 1 to 2 represents the adiabatic compression. And remember, the compression will occur in such a manner that the temperature of the air will be raised to very high values. So the temperature, what is the final temperature as per the diagram? T2. So from T1, the temperature will be rising steadily to T2 during the compression stage, and this T2 will be well above the auto ignition temperature of diesel. Auto ignition temperature of the diesel. So what is my auto ignition temperature? This T2, let me write first. T2 is higher than the auto ignition temperature of diesel. That is the specialty here. Okay, what is my auto ignition temperature? It is the ambient temperature or temperature of the surrounding above which a fuel will get fire automatically. So you need not give any fire source. If the temperature is well above this particular temperature, this threshold temperature, the fuel will be catching fire automatically. So every fuel has got its own auto ignition temperature. For example, for a knowledge, if you consider petrol, you know, petrol is a easily combustible fuel. So if you consider the petrol, so the ignition temperature of petrol is around 280 degrees Celsius, 280 degrees Celsius. So in terms of Kelvin, you can say it is some 553 Kelvin. So above 553 Kelvin, petrol will be catching fire automatically. So no need of any spark to ignite petrol. So this temperature is enough to get it undergo combustion. So that is the meaning of auto ignition temperature. Right now, compared to petrol, diesel is having a bit lower auto ignition temperature. So diesel's ignition temperature is only 210 degrees Celsius. So it is 70 degrees Celsius lower than that of petrol. So in Kelvin, of course, you can just reduce it accordingly. Some 70 difference can be made. So it will be 553 minus 70. So that should be some 483 Kelvin. So the meaning, this data you can remember if needed. So if diesel is compressed to a temperature above, if air is compressed to a temperature above 483 Kelvin, that is a very suitable temperature for the diesel to catch fire. If you just spray some diesel to this particular air maintained at the temperature, automatically without the use of any spark plug, diesel can undergo auto ignition, and that is a basic principle in the working of a diesel engine. That is why there is no any need of a spark plug in the case of a in the case of a diesel engine. So we can call that this is actually compression ignition process. So this type of engine is what is known as compression ignition engines. So where the role of a spark plug is taken up by just adiabatic compression. So already you learned that adiabatic compression always results in temperature increase. So that is a thing to be taken care of. So in process 1 to 2, there is a quasi-static adiabatic compression of the air happens, and temperature of the air will be raised to such high values which is well above the auto ignition temperature of diesel. And in usual cases, the temperature T2 will be of the order of some 1000 Kelvin. You can see that is well above, almost double of that of the auto ignition temperature. So the chances of diesel getting burnt or undergoing combustion the moment it is sprayed is so high, so such conditions are prevailing inside the cylinder. So now at this stage what happens is that the supply valve actually, so at the end of the compression stroke you will see that the supply valve will be getting opened, and the fuel supply valve will be getting opened, and the diesel under high pressure will be sprayed into the cylinder. Diesel at a high pressure will be sprayed into the cylinder, which contains air above the ignition temperature of diesel. Okay, and the spraying makes the diesel particles into very fine particles, so that it can easily catch fire. You know that unlike petrol, which easily catches fire by a single spark, diesel won't get fire very easily. There are reasons. The very basic constituents. Diesel will be catching fire only if it is split up into very fine particles, and also there should be favorable conditions for that. It won't easily catch fire like that of petrol. Okay, so that is one thing to be noted. So that is the process that is happening during 1 to 2. So that is the compression of air to a temperature well above auto ignition temperature of diesel. Okay. So then let's come to the process 2 to 3. I told you this process 2 to 3 distinguishes the working of a diesel engine from that of a petrol engine. So in the case of a petrol engine, as I have mentioned earlier, you can see that 2 to 3, what I am just drawing at the bottom, 2 to 3 was an isochoric process, because that was initiated by a spark, and the combustion happened so rapidly. But in the case of diesel engine, you can see the process 2 to 3 is occurring at constant pressure instead of at constant volume. So how the process can occur at constant pressure? Because you can see that there will be a sudden release of some energy, and how to maintain the pressure as a constant. So to maintain the pressure as a constant, the secret is that the piston will be moving a bit backward, not too much. Piston will be just retracting. So the piston will not remain at the position. So actually you will see that the piston movement occurs during the stage 2 to 3. in the case of a diesel engine, whereas the piston was remaining there itself in the case of gasoline engine. So actually, but even then we don't call stage 2 to 3 as a stroke, because the complete movement of the piston doesn't occur. Okay, so remember, during the stage 2 to 3 in the case of a diesel engine, the piston will be retracting for a very small, just see the distances, so that the volume will be increasing from V2 to V3. So that is why there is a there is a point V3 having volume V3 in the PV diagram. So remember, in order to maintain the pressure constant during combustion process, the volume will be increasing. Volume increases from, I can say, 2 to V2 to V3. So you can just note that in the case of PV diagram. So I have already mentioned that this V3 will be intermediate as that of V1. Okay, so V1 is the full volume, so you know that is a piston diagram, so you can see that V1 is the complete volume, so this is V1, whatever is there inside is V1. Then V2 is the dead center volume, so this whatever space left out, this is V2, and of course V3 will be very close to this one, so whatever is now here, that is what is known as what, V3. So I think I clearly understand that. See, during this process, of course, the combustion occurs, so that there will be a sudden increase in the temperature. So T2 will be just increasing to T3. So V2 increases to V3, and the temperature rises as a result of the combustion of the fuel, means which is diesel. So T2 to T3, it increases. So the role of air here is to just produce a favorable condition, means the sufficient temperature, in order to begin the combustion of diesel, which is the fuel over here. Now see that there is one thing, the flow of diesel into the cylinder will be controlled by the fuel injection valve or the fuel supply valve, and the fuel supply valve will cut off the supply of fuel once sufficient amount of fuel has entered the cylinder, during a cycle. So that is actually controlled by the fuel supply valve, because I will come back to this particular stage 2 to 3 later when I discuss a concept what is known as cutoff ratio. We have explained the compression ratio earlier. We will define one more ratio known as the cutoff ratio later, so I'll come back to the role of this one later. So now let's proceed with the next stage in the diagram, that is 3 to 4, and there is nothing to say. Process 3 to 4 will be representing the quasi-static adiabatic expansion, the same stage that the case of gasoline engine, and that is the stage during which power is delivered, or useful work is done by the engine during stages 3 to 4. So that is represented by the adiabatic curve 3 to 4 in the diagram. Now process 4 to 1, what is a process 4 to 1? Process 4 to 1, it is the exhaust process, during which the exhaust valve will be getting open, and the difference between external pressure and high pressure inside the cylinder will cause an automatic outflow of the combustion products. So that is happening during process 4 to 1, and during this process only what happens, an amount of heat QL is actually removed from the cycle. Now and finally we return to the initial stage by following process 1 to 5, which is nothing but a quasi-static isobaric exhaust stroke, during which the stage process 5 to 1 will be running in reverse sense. What happens is the remaining combustion products will be removed by the upward movement of the piston, and the cylinder will be cleared for accepting a fresh lot of air to be compressed in the next cycle. So here I can say that the pressure is P is maintained at P0, and the volume will be reducing from V1 to, you can see that V1 to 0, and the number of particles will be reducing to N to 0. So that is quite just the opposite of what we have mentioned in the case of the first stage. So that is the machine is now ready for accepting a fresh lot of air and ready for another fresh cycle. So that's about the basic working of a diesel engine. What we have explained is air standard diesel cycle. So it's always good that you compare its working with the working of a gasoline engine. You note the differences. As I already mentioned, the major difference is in process 2 to 3. Okay, whereas it was quasi-static isochoric increase of temperature and pressure on combustion. In the case of gasoline engine, here it is an isobaric combustion that happens in the case of diesel engine. Hope that is enough for the session, and we will derive an expression for the thermal efficiency of a diesel engine in the next session. Thank you.